Hey guys, welcome to part 1 of my income expenditure model, or the Keynesian Cross diagram. In this one I'm going to build on my last video where I introduced the aggregate expenditure line, and we're going to talk about equilibrium and what happens when we're out of equilibrium in this model. In my next video I'll show you how to use this model to create an aggregate demand curve. So, here's our plan for today. First, I'm going to remind you a couple of important things about the aggregate expenditure line. And if you want more, just look at the previous video in my intro Econ playlist. Or I guess probably up there in the corner if I remember to add it. Second, we're going to talk about the significance of that 45-degree line. We'll talk about equilibrium, two different situations where we're out of equilibrium, and then a multiplier effect. So that's our plan for this video. If you're not interested in any of those things, go watch something else. Here's 3 graphs that will help us get started. Let's start with the aggregate expenditure line. The aggregate expenditure line is equal to the consumption plus planned investment plus government expenditures plus net exports. So it's almost like GDP, except with GDP, the investment wouldn't just be planned, it would also include unplanned. So this is only accounting for the plannable part of the investment in GDP. So this is almost like GDP, which is C plus I plus G plus net exports. The difference is we're ignoring the unplanned inventory investment in this line. It only accounts for things that have a real plan. Let's see. We treat these 3 variables as exogenous, meaning they're chosen outside the model, and we hold them constant within the model. If you move any of those, you're going to need a new aggregate expenditure line. And our consumption function usually has a form kind of like this: A plus MPC times Y. That is what we put in for the consumption function. And so A is some autonomous level of spending, MPC is the marginal propensity to consume, and it's the slope of the line. If you want more details on this, I do strongly recommend you check out that video before you continue. Now, let's go to this middle graph. All it is a 45-degree line. In my last video, I told you that in equilibrium, aggregate expenditure is going to equal GDP. In other words, unplanned investment will equal 0. And then aggregate expenditure will equal GDP. Well, the 45-degree line helps us because I don't know how familiar you are with the geometry behind it, but when you walk along a 45-degree line, Y will equal aggregate expenditure at every point along this line. That's the significance of it. That every point where aggregate expenditures equals GDP is to be found directly along this line. Every single one of those points is a potential equilibrium, and no equilibrium exists except it's on that line. So we bring them together, and what do we see? Well, we call this diagram the Keynesian Cross, or the income expenditure diagram, or income expenditure model. It's up to you. But first thing I see is I am drawn to the point where these lines cross. This is your equilibrium, where aggregate expenditure equals GDP. Now, how do I know that that equals GDP, though? Well, the red line tells me every point where those two things are equal to each other, where GDP equals aggregate expenditure. This intersection is the only point where the blue line touches the red line. And so that is where aggregate expenditure does in fact equal GDP. But let me blow this up onto a bigger graph so we can work with it more. I have equilibrium marked on here, Y equals AE, which means that unplanned inventory investment is equal to 0, and everything is stable. This is macroeconomic equilibrium. This is the stable level of GDP. This is associated with potential GDP. Now let's talk about a lower y. Let's talk about some y prime that is less than the equilibrium y prime. Well, at this y prime, I can look at the aggregate expenditure line, and I see an aggregate expenditure there. And I can look at the 45-degree line and see what the GDP is at this y. Now, of course, I could just look at it along this axis, but then it becomes harder to compare because I'm comparing horizontal motions or differences with vertical differences. The 45-degree line, on the other hand, allows me to convert this horizontal difference into a vertical one. And once I have that, it's easy for me to compare GDP to aggregate expenditures. In this case, I can see very clearly that aggregate expenditures are greater than GDP. So, at this y prime, aggregate expenditure is greater than GDP. Now, based on this, what do we know about the unplanned inventory investment? Well, I told you earlier, if aggregate expenditure is greater than GDP, that means we have negative unplanned inventory investment. How much of it? Well, it's this gap here. And it is negative. It's less than 0. So, what happens if we have negative unplanned inventory investment? We need to understand what that means. If we have negative unplanned inventory investment, that means that your inventories are emptying or falling. That means you're selling stuff faster than you were planning on selling it. So we're doing lots of business and we don't have enough stuff on the shelves. So what do? We are going to increase Q, or output, which means our GDP is going to go up. And then as a side note, if GDP goes up, all the other business cycle stuff can happen too, right? Like unemployment can go down and stuff like that. So what just happened? We were at a low GDP, less than our equilibrium GDP. And because of that, people were buying more than our economy was producing. So our economy increased production in order to meet that demand. Production goes up, Y goes up, GDP goes up, and this Y prime is going to move towards Y star. Now, what about over here? We'll call it Y double prime, okay? Well, over here, we can see that aggregate expenditure is less than GDP, and the gap between them is also unplanned inventory investment, but in this case it's positive because GDP is higher than aggregate expenditure, which means our inventories are building up. Well, if you're running store and your inventories are building up, what do? You are going to slow down production. You're going to decrease the Q that you make. Now, why is that? Well, your stuff's piling up. People aren't buying it as fast as you're making it. You have to produce less or you're going to run out of space. But if you decrease production, that means you're going to see GDP fall and your unemployment rate rise. You're laying off workers because you're not making as much stuff. And so we get this situation where if GDP is higher than equilibrium, well, our production outpaces what people are actually spending. And so our inventories build up, so we cut production. And when we cut production, Y prime shifts left towards the Y star. And this feedback loop, ranging between the inventory investments and the changes in production, that is what makes this mark the equilibrium. Because if Y is less than Y star, inventory is empty too fast, we increase production, which increases Y. And if we're to the right of Y star, inventories are piling up, so we decrease production, which decreases Y. This is the macroeconomic equilibrium. So what happens if there is a change in aggregate autonomous spending? Now, what on earth is that? Well, it includes a lot of different things. It can include a change in A from your consumption function, a change in G, government spending, a change in planned investment, or a change in net exports. Any of those things that we had built into our aggregate expenditures line, including this A from your consumption function. Any of those, like just numbers, A or G or IP or NX, if any of those change, it's going to change our equilibrium. For instance, if G increases, aggregate expenditure will increase, and we'll wind up at AE2. And when we do, there's going to be a new macroeconomic equilibrium. Now, I could get into like a little side discussion of how if we're still producing at Y1 when G increases, then we're going to see negative inventory investment, and that will trigger an increase in production, which brings us over to Y2. That's a different story than what I'm trying to tell right now, but it's all potentially useful. What I want to talk about is if G increases, or any of these aggregate autonomous spending categories, how much does it increase Y star? So I'm going to give you an important result now, which is that the change in Y star is equal to the change in aggregate autonomous spending, which again can encapsulate any of those categories, times 1 over 1 minus the MPC. That's an equation for you to remember. Remember, the MPC is the slope of your aggregate expenditure line. MPC and 1. The slope of that line, 1 over 1 minus MPC times the change in spending, is the change in GDP. Now, if you're in my principles class, you might not need to know as much math about this. You might just need to memorize this equation. I'm going to show an example or two of what to do with this. But if you're wanting to actually practice some math, guys, because some principles class might make you do some, stick around at the end and I'll show where this comes from. So, for example, say we have an aggregate expenditure function that is 1,000 plus 0.8 times y. Well, we know that the slope of this function is the MPC. That's the MPC. So our multiplier, 1 over 1 minus 0.8, is 1 over 0.2 equals 5. By the way, quick side note, this is 1 minus MPC down here, which means that this is MPS over here. I could just as well have written this as times 1 over MPS. That's the same thing. I'm not going to emphasize it though. Now, what does this multiplier of 5 tell us? Well, a multiplier of 5 means that if my aggregate autonomous spending, say our change in government spending, was equal to $1 billion. Well, how much would that increase in government spending change GDP? Change in GDP would be $1 billion, I'll just say 1B, times 5. $5 billion. It multiplies that change in spending around. Now, why does it do this? Remember back to your circular flow diagram, if we spend a bunch of money, someone else collects it as income and then they turn around and spend it. The dollars go around and around. This model is helping us to see that when we change something in our economy, that money will go around and make for a bigger change. Let me do another example real quick. We had a change in net export, where we started producing and exporting a lot more stuff, and so our net exports went up by $500. And let's say we have an MPC of 0.6. Well, our multiplier is equal to 1 over 1 minus 0.6 is equal to 1 over 0.4 is equal to 2.5. Which means that our change in GDP is equal to 500, because that's the autonomous spending change in this example, times 2.5, which is $1,250. If any of these things changes, it will create a multiplier effect, and the eventual change on GDP will be bigger than the initial change in spending, which is a pretty cool result, honestly. Now, if you don't have to do much math in class, this might be as far as you need to go. But if you're interested, here's just a little bit more math to go with it. I'm not going to go crazy, but I do want to show more. Let's say our aggregate expenditure line looks like this. There's some autonomous level of spending, the combination of the autonomous consumption plus planned investment plus government spending plus net exports plus MPC times Y. And we also know that in equilibrium, AE equals Y. So I'm going to substitute this equilibrium result right there. So I'm going to make it so that this equation is only true in equilibrium, but that means that Y is equal to AAS plus MPC times Y. Now let me fast forward just a little bit. I'll leave the steps in writing, but I'm going to skip them. This equation, that is going to be true in equilibrium, guaranteed. But that means that if you're going to increase your autonomous aggregate spending, it's going to get multiplied by this thing and increase Y by a bigger amount. This is where it comes from. It's not hard to do this little extension. I don't know if that helps you or not, but I thought it was useful, so I wrote it. But thank you for watching. Good luck and happy econing.